like to switch it off. I was very amazed. Is my father a magician? So that's why this, and later in my life, I realized it was basically electronic circuit that he had developed that was making that happen. So, but as I grew up and went on to do my masters at the University of Science, my professor again, Professor Atanu Mohanty from Supercomputer Education Research Center, he always used to help me build prototypes on new concepts, new ideas. And
Ganesh, sir, excuse me, Ganesh, it is Shankar speaking. Can you make your screen full screen?
Yeah, sure, sir. I'll make it this one full screen. I'll start with the screen. Yeah. I always had learned a lot of prototyping is part of my master's as well. And that 2 years of my time at the University of Science, I worked with a bunch of different team members from different branches, from mechanical, electronics, electrical, civil engineering. So I got a diverse understanding of how prototypes are built. And as I worked with General Electric, I learned more of, really how a multinational company would look at taking a prototype to product level, right? And I had an amazing experience working with the team in Grand Rapids in Michigan, that's in the US, on taking an idea prototype to a different level. And then I moved to GE Energy business, that is energy transmission and distribution business. So we had this thing to build a energy meter in 6 months' time that would go to Australian market. So again, there are already existing some designs, but we had to do it according to the specification of the market in Australia. So that was again a very accelerated process on doing the entire design and then prototyping and testing it and making it ready. So while I was in an aviation industry where things were kind of generally takes 8 years to take an idea to build the product and go to the field, because Federal Aviation Authority always had a lot of stringent compliance which had to be matched. But on the other side, when energy transmission and distribution, the cycle time was very short. So all this experience kind of really helped me to gain knowledge, whether it is my engineering days in RV college or my first job in a startup, or even for that matter in between, I also worked with ISRO as an intern, and then my master's, and then there's different phases of learning prototype. But where I applied the most of this was in building renewable energy systems as part of my startup that I started, FluxGen Technologies, back in 2011. Right. I also had a brief stint with Celco Solar, again, Dr. Harish Hande, or most of you might be aware of. So I had a thing of working in Celco, and we had built some renewable energy systems in Dharmasthala and other places. Renewable energy based water purifying system we had actually built. I think that still exists in Dharmasthala today. That was funded by SKDRP. So, so my experience, all this experience kind of really became handy in designing how a prototype should be built and how do you take it to the field, right? So this presentation of mine, I would be breaking it into multiple places. I would not be talking about any specific branch because this is a very fairly generic presentation, not related to any particular engineering branch, but I would also give emphasis on how different branch of engineering played an important role in different ideas. So I would be talking about how coming with an idea, a concept stage led to implementing it, and then leading to implementing a prototype at a laboratory level. In my case, it was in a lab. Fortunately, I had a table tennis board in my lab where it became a test bench. I would be sharing about that. And then I would be talking about installing a pilot system. So once you have built a prototype, what are the steps taken to implement it on ground? So on ground is very important, right? So that is something that I will be sharing in this presentation. And once you have actually built this pilot system, how would you take it to product development? What are the challenges involved in it and field issues that you are going to take care? I would also spend a little bit of time in IoT value chain, because IoT again is a it cross-functional field where you have people from various fields. How IoT value chain is played a very important role. And I would also say that this was also very collaborated with IoT Congress while building this. So that's why you would also see the logo here. So, so I'll also, it's not possible to show and demonstrate anything, but I have kept an example so that you can understand how to build a demonstratable IoT systems, right? So let me, I have about an hour to present, so I will be presenting it, but I would like to have question answer session after that. So ideally, it'd be nice if you can actually make notes of what question you could ask me after the presentation. If there's something if you want any clarification at any point, please feel free to stop me. Happy to clarify. In between, if I feel like asking, open for any question, I'll also open up in the middle. But as I said, I want this to be a mutual learning experience. So when you ask me questions, that's when it becomes a mutually learning experience. I also fondly remember one of my time at National College, Bangalore, where Professor H. Narasimha had always asked, don't accept anything without questioning. So Prashnisari Opabedi is what he used to tell us. So please feel free to ask me any question. Happy to clarify anything at any point of time, and more than happy to have a longer Q&A at 8 o'clock or 8:10 time. Okay. So this block diagram that you can see is an important block diagram in my career, right? Because this is how I started building the company called this FluxGen. Right. After leaving my job in GE and working in Selco for a duration and taking a break and starting the company, I was very keen on building microgrids, nanogrid, picogrids. It's a matter of nomenclature depending on the number of houses. Basically, how we could power a bunch of houses autonomously. Can you actually generate electricity remotely and distribute this power to a bunch of these houses like a small network? So it's not that microgrid was some kind of an invention or anything, because the earliest grid probably when it was a microgrid, because basically the number of houses were limited. But the fact is, there is always this question whether it is best to be powered by a grid, or is it good to be powered by individual house solar system. Individual house, if you can power individual house by solar system and using it, is it best, or can we be part of a grid? So I always felt the answer lies in between. So it could be generating the electricity is one thing, and distributing is another thing, and consumption is other fact. If you could actually strike a balance, like have a solar plant and not just utilize it to one house, but distribute it to a bunch of houses, probably you would take the advantage of pooling of resources. Time and again, we have understood that pooling of things is always help, whether it's going from my home to a place in Majestic by pooling with other 3-4 people in a car, or me going from here to Bangalore by a train. So the amount of energy resources utilized is always reduced per capita when it is pooled, right? So it's always good to pool things, but at the same time, there's also an advantage of restricting the pooling size, right? So that's what a microgrid is all about. So we wanted to see how we could generate electricity in a remote place, especially in a remote village, and distribute this power to a bunch of houses, say 10 houses or 5 houses. So this was the idea that I had in mind when I came back, and I actually presented this idea. I thought if it is powered by solar, it's great. We can also have an additional source of power by wind turbine or something, that's even good. And if there is during a time of festival when the power requirement is more, we could even put a diesel generator set, or so if there is any grid penetration, then we could also partially power it by grid. So this was the idea that I had, and I actually expressed it to a bunch of people whom I told, like, I want to build a microgrid, something like this, that I could people could actually utilize and can actually use electricity where, especially places where there is no grid, right? I mean, we know India is not fully electrified, right? But there's a lot of effort that has gone in that direction. So, but then this was just an idea. So this is a two-dimensional sheet of paper. I'd come up with this idea. Then everybody told Ganesh, good, that I know you're a graduate from Ministry of Science. You worked in GE. I know you have all this credential, but I don't know if this would work or not. I mean, like, I don't see anything real. I don't see something working in front of my eyes. It's just an idea. So when people told me that they want something working, then that's when I realized probably I should build a prototype of the system. That's when it makes sense, right? I mean, then people would see how it would eventually be in the field and things like that. So that's when I actually decided to implement a prototype of this, right? I mean, implement a system that would showcase the not just the functionality, working of the system. So this exactly is the reason why you need to build a prototype. You want to not just showcase the functionality, you have to show the working of it, right? So not just only a diagram that I showed before. So we started actually building a lookalike of a microgrid of what that picture I shared. We started putting things in a table tennis board in our lab. You can see some of my interns and colleagues in this picture. We actually put up a house-like kind of thing in this prototype, right? And then we not only got that, we even put a colored it out and made it look like a real microgrid. We wired this bunch of houses with actual street light, and we also kind of put this house with electric bulbs and sockets and things like that, right? You could see this here, right? So the thing is, this is, you can see this electric socket here, and you could also see the energy meter here, and so we even powered this microgrid. I mean, not just only putting that sockets and things like, we powered this up, right? I mean, so this is how the microgrid looked like, right? I mean, the microgrid was actually functioning with all this energy meter, lights. It was also powered by solar plant and the rooftop, right? So after all the clearing and everything, it was ready to present. So we actually started presenting people how are we actually identifying this microgrid. After seeing this prototype, people could get the concept much better, and they could see the functioning very well. Not only that, we had put this energy meter here, which was actually showing the readings, and we developed the software. So we called it as FluxGen Smart Renewable Energy Microgrid. So the software was able to help people understand how are we distributing power to this microgrid. How much is the energy generated by this microgrid from the solar plant? How much is the individual consumption? So this was very powerful, right? I mean, people were actually happy to see the full-fledged functionality of this microgrid. This is where building a prototype really helped, right? So my thoughts on this is, if at all you have an idea, like I showed you on a sheet of paper, see how you can build a functional prototype, whether it is in terms of building a model and then building putting hardware into it, and also putting a software into it, right? We were very fortunately, we were successful in building this microgrid model in prototype, and that's when people started inquiring about what is the cost of the system, where can you build this, how much would be the electricity required to build a microgrid. So people became serious. So at a very fundamental level, what I'm trying to tell is that to get people serious about a project, then building such a model is very important, like what you are seeing here, right? So it had electric socket, it had this one wiring, it had even a circuit board. We had used a single board computer to monitor the Modbus signal from individual energy meter. So and we had put CFL, we had put all this different kinds of lights to monitor the power consumed by individual houses. Right. Another thing I want to emphasize is it's aesthetics also play a very important role. So don't undervalue the importance of design and implementation of it. I mean, don't undermine the importance of the color and the sun feel of it. It's also important, right? So that's my take on aesthetics. So that falls under the design aspect. Okay, so after we built the software, as I said, we contacted bunch of people, and then we were proposing various pilots to be installed in places. Let me talk about this case of solar PV microgrid installation in a place called Mendel in Belgaum district. Belgaum is a place in North Karnataka. It's in North Karnataka, and it's a small village called Mendel in a place called Khanapur Taluk. It's in that taluk. So in collaboration with Divecha Center for Climate Change at the University of Science, that's my University of Science is my alma mater. So I actually presented this work to them, and they were very happy to take this thing forward. And with Divecha Center for Climate Change, we actually presented this microgrid, and they decided to actually go through they were also looking for something like this, and we got an opportunity to do this microgrid in their collaboration. So fortunately, we won some very prestigious award for this work from NI Engineering Impact Award and Global Engineering Impact Award in the energy category at Austin, Texas. Right. So here's the problem statement. We wanted to. The problem was that there's no electricity in these houses. They were inside a reserve forest area. So this reserve forest area didn't have access to transportation. I mean, there was no transportation route or any road or anything like that. Also, no medical facility. So, so this was the problem statement. They wanted electricity, they didn't have. They wanted this one, they didn't have, and they were surrounded with forest. So there is another problem there. For a reserve forest area, Supreme Court had passed a judgment that you can't extend electricity grid inside this reserve forest area for two reasons. One reason was you can't, it would lead to a kind of a forest fire kind of situation if you are extending it inside the whole forest. The second thing is more people living in the forest. If you are encouraging people to live in forest, if you put electricity, naturally people would like to live in that forest. That would lead to more poaching of animals, right? So there is always this problem of human-animal interaction, and they did want to increase the human. This one already there is a lot of cases that I mean. So this was a problem statement. So ideally they wanted, but at the same time they wanted the people to stay in that village so they could actually generate electricity and internally use or distribute. So that's why this problem was a perfect problem statement. So we approached this place called Bhimghat Wildlife Sanctuary in this Khanapur Taluk in Belgaum district. Right, so this is a point where we could actually come over a vehicle, after which we had to almost trek to this place. So you can see it's a huge forest, right? I mean, in between there are houses. I don't know if you could see the houses, but there are houses here, right? And it's a beautiful place. I mean, no denying about it. But as I said, there was no transportation means. There was all this waste you could see. And on the bottom right, you could see the houses here, which were not electrified. This is the houses which didn't have access to electricity because it's in such high terrain and this one. So this place, Mendel, is located inside Bhimgad Reserve Forest. Nearest electricity grid was 5 kilometers from this place, right? And 5 kilometers of non-motable terrain. So there's a lot of challenges in this place. So we actually decided to understand how are they consuming electricity, are they using electricity. We came to know that they were using this kerosene-based lamp, also called as chula, right? I mean, they were using it, which caused indoor pollution. I mean, like indoor pollution in the sense it would affect the women in the family who used to stay there most of the time and cause various other health hazard. There are some people who used to get this battery. I don't know if you can see this battery. This battery used to be, they used to carry it for 5 kilometers by hand, which was actually charged by this automobile, like through this lorry or truck. They used to get it charged every week. They used to bring it, use it for a week, and then take it back and get it charged again, bring it back. Through that, they were also using this one. On top of that, they were using a inverter, a small inverter, 30-watt inverter, which had, sorry, around 30 to 40 watt inverter, and it had efficiency of 30%. A 40-watt inverter having 30% efficiency would further reduce the electricity that is there in this charge stored in this battery. I mean, it's a 100 ampere hour battery, and it would have 50% deep. It's not a deep discharge; it's 50% discharge, right? And on top of that, it has 30% efficiency. Hardly they would get 15 ampere hour of power, effective power. So it was not, they were using very primitive ways of electricity. So we decided we set up a solar microgrid plant. So another very important thing before doing any project is surveying, right? We didn't just want to build a setup there. We talked to these people, understood their requirements. Why would they need electricity? How much electricity would they need? And you could see the pictures with all the people, and of course, the ladies in the village were very shy. They didn't want to get photographed. But you could see all the other people whom we actually talked to, the village mukhyastha, their children, right? There was these kids actually told us, we were like really literally melted when they told they wanted to do homework. There was a school there. They wanted to study and they wanted to do homework there to stay in par with the urban people, right? They told like urban people get so much opportunity. They can go to school and study. We also want to study. We want to do homework. When they told homework, we thought we are doing this project because when I was a kid, I was not doing so much of homework. I felt very guilty of myself when I had all the facility being in Bangalore. I didn't do all the homework. These people don't have electricity and they want to do homework. That's when we decided we are doing this project. And we took help of the Vivecha Center for Climate Change for funding this project. And we spoke to the Shiroli Gram Panchayat. That Panchayat, we spoke to them and told you want to set up the microgrid. They told it's a very good thing that you want to set up microgrid, but according to this one forest rules and regulations or forest, you can't actually get any special land to set up this microgrid. You have to utilize the land by these villages, right? So, and they also told you have to take permission from forest official to transport goods inside the forest. So that's very important. What I realized is government compliance is very much important. We can't neglect and do things. So we took all the permissions and we started setting up this microgrid. So what is very important is understand from whatever prototype you want to build. Always don't understand what is the law of the land and being compliant to law of the land is very important while we build solution. So we took proper permissions and then we started building microgrid, right? So I have to tell you because we thought initially we thought let's not put any electric pole. Let's put wires underground. right? So we thought if we put wires underground, then there's no problem with wires and all those things. But when we told these people, no, we are not putting electric pole. The villagers told, if there's no electric pole, then it's not real electricity. It's some not. We were very surprised. I mean, we were like, I mean, basically, I understand electricity, but the problem is we have to understand that we have the privilege to understand many things, but many villages don't understand what we understand. So for them, they have seen electricity in cities where there's an electric pole. So they wanted a similar kind of feel of electricity in their place. So then we told, okay, if you want electric pole, we'll put electric pole because that's when you get the complete feeling. Then we thought if we are also putting electric pole, let's put street lights also because the village, many times, many women in the village have to go for urinal or so outside. I mean, for this one, and they feel very uncomfortable going in the without light and night. They feel very uncomfortable. So we thought it's good to have street lights so that the village women also feel comfortable going out in the night to urinate. Right. So then we decided to put even street light. Right. So this is how we came up with this idea. I mean, we decided to put street light. So you can see here, we put up this 2 kilowatt solar plant. Each of the panel was 250-watt solar panel, polycrystalline solar panel connected. So the polycrystalline solar panel it was, I think, 60 cell polycrystalline solar panel. All the solar panel were connected in series parallel arrangement, 48-volt system. And we used this person, Mr. Ramesh, there, his place only to set up the microgrid because the forest officials clearly told you can't take any land of forest land, you have to take help of the this one. So Mr. Ramesh is the Mukhyastha of that village. So he volunteered to give this small solar plant space to put up the solar plant. Right, so we put up this wiring and things like that. Exactly like how we had put up the exactly how we had this uh, electricity meter in our prototype. I showed you the table tennis board. We put up the same kind of electricity meter, and since we had written the software, we had developed the hardware in the lab. We didn't have to put an additional effort in the field. So that's what I would recommend you all. While building your prototype, understand the final requirements. Once you understand the final requirements and when you build the prototype, then most likely what you build the prototype would work very well. Right? So we were able to build all these things together and we were able to. Another thing is, since it was powered by Divecha Center for Climate Change, they also wanted energy meter data along with weather data because they wanted to see if we can actually get incoming solar radiation. How much is the incoming solar radiation? How much is the weather data in terms of wind speed, wind direction, and humidity, temperature? All these parameters play a very important role. These are called environmental parameters as well, weather data that also have an influence in electricity generation, right, from a solar farm. So since it was also a research project, we actually put up this. We took the help of the villagers to set up this microgrid, right? And so I mean, in terms of this one, and they helped in setting up this thing. We got the longest possible pole there. Of course, we wanted to put it further height, but this was the thing that we could get. You can see the village boy happy, elated with setting up this pole along with his father and happy with my team. So we set up this wind weather data as well, right? We also put up all the possible sockets in this microgrid, right? So basically the sockets mean 2-pin socket and switches and everything. We didn't give any 3-pin socket because this microgrid was with limited power. So we didn't want any kind of this one in it. Right? I mean, problem in putting a iron box or something like that and causing any trouble. Right. So basically, we put up this thing, and it was a very good electric. We took another thing we did was we took local electricians' help to do a work. So this is what I would recommend. Don't always do the work yourself. Try to use local support, because a village like that, if you want to do something, there'll be a lot of uncertainties. So when you employ a local support, they would cover the uncertainties, right? So because they are living there. So we took the help and it came out really good. As I said, we deployed the software and hardware there. You could see my colleague Tejas with the laptop. He was configuring the hardware, configuring the software, everything there, right, inside this. And it didn't take more than a day because we had done a powerful prototype at the lab. So when the lab development was so good, it became much easy to deploy it in the field, right? This was on the back side of this house. In Kannada, they call us Hitlu Kade. But anyway, this is a place where we had actually put in the backside of this thing, control panel. And we had put the energy meter. We would know how much is energy consumed by the whole grid and how much is the whole electricity consumed in the whole microgrid and electricity consumed by individual houses, right? So this was a good project. And you could see the overall block diagram of this microgrid. Right? We had the solar plant, which was a 2 kilowatt solar plant. We had the charge controller and solar inverter. So the charge controller would get electricity from the solar panel and would charge the batteries. We had around 800 ampere hour battery totally in cumulative. I think 200 ampere hour each, and 4 of them. We had put 800 ampere battery there. And we had connected it to a smart monitoring system, right? This is where the IoT comes into picture. So the smart monitoring system would know how much is the electricity generated by the solar PV plant, how much is the electricity that is going to this battery bank, how much is the electricity that goes to the weather station. So all these things we were able to monitor. I mean, sorry, weather station wise, we were able to monitor the temperature, humidity, rainfall, incoming solar radiation. All this data was going through this smart monitoring system. So this was a GSM based system. You could actually send the data to the cloud. Interesting fact, in India, we have network connectivity, but not electricity connectivity everywhere. So this plain and handy. And we were also monitoring the energy consumed by individual houses. Right, so this is how this IoT system played a very important role in sending the meteorological information, and even we were even shutting down the power in individual houses if they are consuming more than stipulated amount of power. So if it was since the solar plant is a 2 kilowatt plant, the amount of energy generated by the solar plant was around 10 units of electricity. 5 into 10, 5 to 10 units of electricity was generated. There was like 5 houses. Each house could consume maximum of 2 units of electricity. If they're consuming more than 2 units of electricity, it would not allow. So this was how we had used a smart monitoring system to even regulate the power to individual houses, right? So I'm happy to stop here, and if you have any question in this thing, ready to take. Any question on this block diagram of this microgrid? Because if you have any question, I
can. Sir, we have specified the question and answer session at the end of it. Is that okay for you, sir?
Absolutely fine, sir. I think happy.
So that it will not be a disturbance for your flow.
Absolutely, sir. Absolutely.
Yeah. I am noting down all the questions. I have requested all the participants to post the questions on the chat box. I am noting down, and I will ask you at the end, sir.
Absolutely, sir. Thank you so much.
Thank you, sir.
Basically, this is the block diagram of the micro smart renewable energy microgrid, and I'll be happy to take any question at the end about if you have any doubts on the configuration, settings, and things like that. So this is how this little girl could get electricity, see electricity in her life. While her brothers and the father and the male members in the family had gone to various cities but and seen electricity, this girl had never seen electricity in her life. And she was very happy. I mean, you could see hope in her eyes. She was very happy about it. And today she's even going to college. I should also say, setting up this microgrid gave access to setting access to electricity, light, and the kids in the village were able to study. And I should also say that the passing percentage, 10th standard SSLC passing percentage, drastically increased after the setting of this microgrid. More students, like there's I think 70% more people, more students passing in that village because of this microgrid. Right? See, imagine electricity having an impact on education, so and people's safety and things like that. Right, so that's why I feel this project was a very one of the most dream project, happy project that we did. I also felt like most of my education was public funded. I mean, I went to government school and public funded. I mean, mine was a government seat in Army College, and I got scholarship all from taxpayers' money. When I happened to do this project along with my team, I felt at least there was some justification of that money from all the taxpayers to do this project. So yeah, they also got television, you know. I mean, it's just not when you get electricity, the children they got television. They were able to even access entertainment program as well. See, for us, entertainment is in so much in surplus. For them, at least seeing the television, they came to know how the world is. They could also access EduSat, Doordarshan education programs. So it became a level playing field for these villages. So the electricity and all this television became a level. We were actually setting up a level playing field, right? So we were actually able to get this. We also had this. They were able to use mobile phones, and they were able to see. We also gathered the data from the IoT system, right? We were able to see how is the electricity generation patterns, incoming solar radiation, how was the electricity consumption. So you can see the day 2015, 8th May, it was a very sunny day, right? It's still in summer, May is still summer, right? And then we could see when they could get full access electricity, and they didn't even switch off the electricity when they slept. You can see they literally were switching on. But on the day when the electricity generation was less, because sunlight was, it was a very overcast day, they were having limited power of electricity. So this is a very important thing that I want to tell you, that when you have a lot of electricity, sunlight, you tend to overutilize it, right? And but when there is a this one, like day when there's less sunlight, you may have to actually put increase the battery sizing. So this is an interesting thing. The number of days of autonomy is also important while you do the battery sizing in a solar plant. So so this was a very interesting observation. In fact, we also understood, we further did some analysis on a given day based on the incoming light on this one. On a day when the sunlight was minimum, the consumption was maximum, that we came to know afterwards, right? Because, you know, when their incoming solar radiation is less, that's a gloomy day. So people want to sit at home, and if there's a rainy day, they want to consume more power. So this gave us some interesting analysis. In fact, we use all this I'm sharing here is now available. We presented this work in IEEE Smart Grid Conference in Miami. This was organized by IEEE Communication Chapter. And we were able to present this work in, it's of course in Florida, the US. This was very accepted well in the conference, and we got many interesting suggestions. on how weather data was interlinked to the energy generation and consumption data. Right. So happy to share this paper after this conference. I'll be happy to share it to Professor Rajshekhar, and he can share this paper with you all. Right. So let me now come to the next stage of this one. So of course, next comes is once you have actually deployed a solution in the field, now it's about what are the challenges that you would face, right? And so we actually understood it in a, so while it was very specific to a project like a village, we also decided how we can make it a product, because project is basically one requirement. So project was basically how we can apply this in both rural and urban context. And we started thinking about building a generic energy monitoring system. And then we also realized if we are doing energy monitoring, we can also do water monitoring, right? I mean, because if you are setting up a network, why not even monitor water, right? So we came up with something called Energy and Water Manager, health monitoring system to know how much is what is the health of the system when we put it in a deployment. So we made all the 3D diagrams to come up with. We came up with a new user interface, and this was very helpful to build a wireless sensor network system, right? So, and then we, for the urban setup, we decided to make a apartment kind of thing, just like how we made a prototype of a village. We made an urban setup like an apartment, how electricity would be consuming and how water can be consumed in the setup. So we were again monitoring the system using a energy meter, flow meter, and all those things. So we even showcased in various events, and it was a very successful demonstration. And then we came to know that many people would want, along with energy monitoring, they want water monitoring. In some cases, they wanted water monitoring system only, right? So this was terrific. I mean, like, people started contacting us, and we started growing our business and things like that in villages and apartments and buildings. So let me now talk to you about, since I've covered the renewable energy part, let me cover about sustainability in terms of water part. Like a case of solar powered water management system using EW for Titan Jewelry Division. It's a Tata company. Most people know as Tanishq. So Tanishq, makes jewelries. So women here would know jewelry. So there's a great company which produces wonderful jewelry. Men here would have actually got jewelry for their loved ones. So yeah, it's a great company where they are very conscious of water management. While they are selling jewelry, they wanted to be very conscious of how much water is used in this whole facility. So we implemented our energy water management system with water management as specialization in 50 different locations. So what we did was, this facility wanted to reduce water consumption in the whole facility. And they realized if you don't measure, you can't manage, right? If you don't measure, you can't manage. So they wanted to know this one, what is the consumption pattern in each places, and how much is the water consumed by borewell, water pumps, and foresucks, and how is the water consumed in overhead tanks. So what we did was we put up this monitoring solution. What you could see this thing in multiple locations, right? I mean, EWM thing in multiple locations. It was powered by solar panel, and there's a water meter here that used to be sending the data to this EWM. It's a wireless monitoring system. We put this up in bunch of locations. You can see here we put up this in different parts of the facility, like this, and we started monitoring. So we were monitoring the borewell, jewelry, PED, various parts of this facility, right? So there is a water flow and level monitoring system, right? So you could see the dashboard, and you could see the water level in some water level in some A, some B, some C, some D. These are called fire hydrant sums. where water should always be there. If the water goes below some level, it would strike an alarm, because if there is lesser water in fire hydrant, that could it would be very dangerous if there's a fire accident. And the domestic sump is where the water would be stored, and they would be sending it to overhead tank. So this gave very good visualization to this maintenance manager. And we also monitored water in different parts of the facility, water flow meters in a bunch of different locations. If there was a some kind of a excessive water flow, this one would blink. What do you call that some kind of LED kind of thing, as you can see in this image, would blink, and it would alert the maintenance staff to take corrective action. Say before they were doing visual inspection to find out where there's leakage, wastage. Now, because there is this, they would actually go there and take action. They would know there is this problem there, and they would actually take corrective actions. Right? So this is how we actually set up this thing, and that's how we ended up building our. So there are a lot of field challenges in terms of leakages and all those things in using in the underground pipes, and so we were able to help these facility take. I mean, IoT was very helpful in taking these corrective actions, and that's how we actually divided our problem into aquagen. And we decided for water management, we would use this sustainable water management system to find water wastage, leakage, and things like that. So we were able to use it, develop a backward. Initially, we were saying that help industry save 15% of water. Now we can actually save up to 30% of water. So this is how we actually built our solution. So yeah, of course, we got a lot of recognition, and I don't want to spend more time on this. But yes, this was how we actually came up with all this product, leading to build a successful product from taking an idea from a table tennis board, where we had actually put up a. I showed you the diagram of how we wanted to monitor electricity and water. From that idea, we ended up building a prototype in the lab, and then deployed that solution in a village, and then deployed a solution on some kind of apartment thing. From then, built it a real solution to an industry. And today, we are one of the top IoT-based sustainable renewable energy, water, energy management system company. Happy to share this journey with you all. Hope this journey would also help you understand how we could actually build a solution like this, which can be utilized by industry, and society can benefit from it. Let me spend another 10, 15 minutes on how I use, how we utilize IoT to the fullest to deploy the solution. So there are multiple aspects of IoT in a value chain. So whether there is devices where mechanical engineers, civil engineers are involved. Even for that matter, instrumentation engineers are also involved in monitoring. And then there is gateway, where there is a communication network involved, where electronics and communication engineers, telecommunication engineers are involved in deploying the solution. And then there is ingestion of data. More of a cloud computing and ingestion and automation, where cloud computing people are involved in that work, where even MCA people are involved, where MCA graduates are involved, where they would be able to understand where programs are written. Then there is big data, where mathematicians and big data itself is a analytics and statistics based people are involved. And then there's a report and act, right? So then there is the user interface, design user interface, in terms of people who go to NID, and all those people are involved in this thing. So this is how a bunch of people are involved. Let me tell you with respect to design. So you can see a solar plant here, or a wind turbine here. So the device, we have to monitor the parameters. Even in our case, we monitor weather parameters, right? So it's very important that we have a good understanding of mechanical engineering, civil engineering to mount the system and understand various civil engineering parameters to be monitored. Even in terms of water, there is water flow and all those things require what kind of head should be there, what kind of pressure should be set up in monitoring water flow. If it is a rainwater harvesting system, there we are monitoring how can you how do you do the plumbing of this water flow meter? All those things are involved. Design, so civil engineering consideration should be taken care, right? And even in terms of enclosure design of this IoT system, you need mechanical engineers involved in it. 3D printing, all those things are very important. So that's where the device would come. Instrumentation engineers are involved in putting sensors to monitor the temperature, humidity, water flow, water level, solar energy, current sensors, current transducers are involved. So that's why the device would come into picture. And then you have electronics and communication engineers who would actually be using microcontrollers or microprocessors to acquire this data from an analog to digital converter, where these systems would actually give digital signal to the controllers. And then there is, if it is a wireless system, are you using a Wi-Fi system, Zigbee system, or a LoRaWAN long-range wireless, which is a new IoT-based IoT communication technology that has come out. It has been there for a while now. It is got commercialized LoRaWAN system. Then there is NB-IoT, narrowband IoT, which is again, which would be largely rolled out by 5G, but Reliance is already rolling out NB-IoT. Tata Communication is rolling out LoRaWAN. So there is also proprietary communication like Sigfox being deployed for this one. And then there is, of course, GSM-based communication also used to do this wireless connectivity. There is other things like 6LoWPAN and other wireless connectivity also there. And these all would have a gateway where you would acquire signals, just like your cell tower or this one, you could locally get this data. For home automation system and all, people use Wi-Fi, and that's a gateway communication. So communication technology is very important for IoT system, and that's where you would actually send the data to a remote computer. So basically cloud. So cloud is a remote computer. I mean, if you have any difficulty understanding an electronic cloud, I'm talking about a cloud computing. It's basically a remote computer. Basically, racks of computers are put in a data center. There'll be a lot of processors stacked together, and there'll be memory stacked together in this place. And basically, a cloud is a remote computer, and all this data would go there, right? So we have today Amazon giving AWS, Amazon Web Services, then Azure from Microsoft, DigitalOcean, and you have Google Cloud Services. All these are very powerful cloud technologies available where the ingestion of data would go through. So this, whether it is data from your renewable energy plant, or whether it is from your temperature sensor, humidity sensor from weather data, or your water flow meter data, all those things eventually goes to the cloud. So you could have different kind of database. So Amazon has EC2, S3, S2, all different kind of database where you can store the data. There's other database like MongoDB and all those things where you could use. And then Azure has its own tech stack. Then you would have automate. Whether you want to do computation, in some cases you want to do machine learning algorithms like support vector machine or convolution neural network, whatever is the this one machine learning algorithm you want to run, you can learn on the cloud. You can write it on Python or various other programming languages you can use. Basically, you are running it on a remote computer, so it's whichever language that you are comfortable. But Python is considered as a very emerging, and many people are using Python to do the coding. But having said that, there are newer languages coming today that you could utilize. And then you have big data analytics, whether you would use Works has come up with a very good program, Hadoop and things like that. You could use them to do big data analytics. So once you have a larger geography of this IoT data, assume you have put up this microgrid in hundreds, thousands of places, then you would actually have to get data from multiple places. So there should be parallel computing happening. So they would be spread in threads. So that's why you would need big data, and learning Hadoop and all those things would be very helpful. There are many other packages that you can use to do this. Reporting and Act, again, you could consider various user interface development. We could use something like InVision, or there are various applications that you could use. Even in terms of mobile development application, you could use Node.js and various other computer science platform. You could also use some of the people are very comfortable using National Instruments LabVIEW programming platform. So that these are some platforms which are proven to be very good. We have used all Node, we have used JavaScript in various applications. Nowadays, we also use a new framework by Google called Flutter, which is a widgets-based thing to do this report and act. So there are various mobile application platforms. So I would also recommend for prototyping, there are tools like MITE App Inventor 2, App Inventor. So these don't take much. You don't have to take too much effort to do this. It's very straightforward to do using App Inventor. There's a more advanced version of that. These are called Scratch programming. So you can use something called Thunkable to do this. So these are various tools that we have used to do our development. For even the hardware, I would also recommend tools like Arduino, Raspberry Pi also to be used. You can use them to do this development, and they are very good platforms. And prototyping becomes very easy for these systems. We have used bunch of these platform, and I would strongly recommend to use it. So ideally, I would also show a demonstration of IoT based system, but today, I would always, if any of you are in Bangalore, you are visiting Bangalore, let us know. You could also get in touch with me. I can show you demonstration of a IoT based system. So we have this block diagram, we have this energy meter, Wi-Fi gateway and smart home, and through cloud platform, we're able to we can monitor something like a small jig for water flow meter, all these places, and we could monitor this water flow. As I said, happy to share this demo, and so this is something that we can help. What we do is these are this IoT hardware deployed, and we monitor the water flow from this hardware, and we also monitor the water level in this hardware. That would help you in knowing what is the total consumption, and then there's this user interface, and you would also know how much is the energy consumed by this jig, right? So there are various demos that one could say. I'll be happy to share some post-conferences material for you to see this demonstration. Happy to share some more material that you can go through after this workshop, and so that you can equip with this. You could also reach out to me on my email ID. Let me share it in the chat window. So I'll share it here. Just a second. So So I'm happy to take on the question and answers, and happy to discuss further on this topic. So please feel free to let me know if you have any question. I would be happy to answer.
Yes, sir. There are about 6 questions totally from the different participants. Let me go one by one.
Sure, sir. Happy.
One participant is Mandar Sumant. He is asking about how we can use this in agriculture for the water pumping and other tasks.
I think that's a very good question. So, agriculture, by as you know, today we are having a lot of water problem. There's not much water available. What you could actually do is monitor the water flow, right? I mean, like from the pump, and then also monitor the energy consumed by this pump. When you do this, you know how much is the water being utilized in the farm, and also know how much is the electricity that is being consumed. So if you connect a cloud connector, say IoT device, you have the water flow and water level data. I mean water electricity consumption data. Then you know this data is available for taking corrective action. Like if there is a field, you want to switch on and switch off the pump, you can again use mobile app to actually monitor it and know how much is the electricity consumed, and you can actually see if this land has got enough. I mean, the agricultural land has got enough water for making sure that it's all irrigated. So this way, you know you're optimally irrigating, and so you can switch off the pump once the amount of water is monitored, right? So if you know the threshold amount of water is required, because many times you need to know if you put more water, that is also not good. Because of this monitoring system, you can only put adequate amount of water, not more than that amount of water. So this is how you can utilize this monitoring system. You are monitoring water and energy, and use a relay and solenoid to cut off the water flow. I hope I have answered the question.
Hope Mandar Sumant has received the solution for his question. Sir, there is another participant, Professor Devara Siddhappa. He is asking a question like, please tell more about the software developed, which programming language used, etc.
Sir, we've actually used different programming language all this while. So let me tell you, one of the tools we started early was using National Instruments LabVIEW programming software, because it was very easy to develop the code initially on that, and we had got some training from them. So it was very easy to deploy the software using that. Having said that, then we started using, later on also we started using Arduino as well, and we wrote the code in the C programming language on Arduino, and then we were able to get the data. And then slowly we started moving to advanced platforms like C programming on Texas Instruments hardware, Code Composer Studio, and we have also used the Keel software for embedded hardware, and for software in the front end, we started using Node and Flutter, and as I said, Node.js, and we have used JavaScript, and we have also in the back end we have used Python in the cloud computing. We've written the codes in Python, and there are various virtual machines which uses different operating systems. So, for example, Microsoft Azure, we use Windows virtual machine, whereas AWS we used Linux-based virtual machines. So, various software we have used in this application. We've also written codes in R and other languages as well. So ideally, I would say for prototyping, use C programming in Arduino. For Raspberry Pi and other things, you can use Python. For LabVIEW based thing, you can use their own hardware, proprietary hardware which are very good, which is lab use programming environment, graphical programming environment, and Scratch programming, as I said, MITE App Inventor, and we've used a very this one also. Yeah, these are some of the tools that we have used.
Thank you, sir. It was very good and elaborated answer. Hope Professor D. Devarasiddappa is satisfied with the solution what and all you have given. And it was definitely all the softwares which we all of us know, which was used by you. And Professor Devarasiddappa is happy with this answer. There is one more question, sir. What is the minimum cost involved to set up a solar system in regular house lighting with half HP motor pump running for a day-to-day usage? Shall I repeat the question? Should I repeat the question, sir?
What the question?
Could you able to
sir,
get,
I understand the question. Half HP.
Yeah. What is the minimum cost involved?
Around half HP. And you want to run it for about an hour or two, so right? You have to convert it to see how much the power. 760 or 66 is 1 horsepower. 766 or something like that. Watt is 1 horsepower, so it's around 300 watt or so. And depending on the location of the place, where amount of sunlight and things like that, we have to see 2 hours. Then say 300 or 400 watts into 2 around, you need a 1.6 kilowatt hour electricity. So for 1.6 kilowatt hour electricity, we have to know how much is so basically 1 kilowatt solar panel would give you 5 units of electricity. So you need for 1.6 units of electricity, you need 1.6 by 5. So we have to know that's the fraction of solar plant you had to put. So it would be around nearly 200 to 300 watt solar plant. 200 to 300 watt solar plant would cost you around 300 watts. Say 300 watt solar panel would cost you around. I think today's price is around 40 rupees per watt is the cost of solar panel per watt, or even you can get it at 35 rupees also if you're buying in bulk. So I'll just say around 40 into 300 is the cost of the solar panel, and you would require around battery around 100 ampere hour battery. So 100 ampere battery would cost you around 8,000. Solar panel cost you around say 10,000. So yeah, it should be around, and we can do it within 20,000 or so. I think so. I mean, my rough estimate would be that. So, but I can always, you can always get in touch with me through my email ID. I can find out and tell you a more accurate answer. So I could do this calculation within from the numbers that I heard from you.
Okay, thank you, sir. Thank you, sir. Hope that our participant is satisfied with your answer. Sir, I have some question. Say in your presentation, you were telling about health monitoring of the systems. Can you elaborate more on that to the possible extent, because the time is short, I know. Health monitoring, say like, what are the parameters you have used? What methodology you are adopting? Is it condition-based maintenance? In that condition-based maintenance, what parameters? Something like that. If you can elaborate more onto that.
Absolutely, sir. So there's so health by itself, with respect to human beings, it's about the heart rate, and the stethoscope is a very good indicator. But of course, we have to also use different measurements to know our health. For electrical system like a renewable energy system, health is measured based on how much is the electricity generated for the incoming solar radiation. So if there is a incoming solar radiation, say 1000 watt per meter square, that's like what the sunlight you get in Sahara Desert. So you are supposed to get the defined electricity from the solar panel. The panel would have, say, if it is a 250 WP panel, you would get almost 250 watts when you have sunlight of 1000 watts, 1000 watt per meter square. So now, if you are not getting all the 250 watts when you have 1000 watt per meter square irradiance, so then if you are getting say 800 watts, or sorry, 200 watts instead of 250 watts, that means the panel is not in great conditions. If there is some shadowing on the panel, or there is some crack in the panel or something like that. So that is a health, one parameter of health. So there is a health in terms of solar panel level of energy generation. So then there is another parameter. While you might be having a very good panel, but the inverter is not converting the electricity that you have got from the solar energy to conversion. So that means the inverter has some, if it has a MOSFET based, power electronics based inverter, it is not performing well. It is getting heated or something like that, because of which the electricity generated can be low. So that is the other aspect of health. The inverter is not in 100% efficiency, or at least 90% efficiency, which is expected in these days. So if it is the efficiency is like 70%, then again the health of the inverter is not good. Now the battery is another health of the battery, because it's supposed to be deep discharge battery. If it is supposed to be discharging up to 80%, but by 60% itself the battery is not discharging. So then the battery health isn't efficiency is problem. So in a renewable energy system, there is a solar panel health in terms of generation because of this one. There's an inverter health because of your power electronics based thing. Then there's a battery where if you have actually put enough water regularly and you're getting, that's another aspect of thing. So all these things play a very important role. So if these parameters are not in the range of 90% and above, then the health of the system is not good. So you're not getting full benefit of the investment that you have put in the system. That's how I would call the health of the system. And yeah, I hope I answered your question. If you have any clarifying question, I can answer.
I need little more, like, suppose if you want to automize it, automatically you need to identify that the system should come to you. What type of concepts we can adopt there to get the automatic signals, so that it is not working to the design level, it is working at the sub level than the design. If we are to automize, what are the type of signals we can collect and then to process that signals?
Yes, sir, absolutely. So, firstly, if you're in the solar part, as I was saying, there should be an incoming solar radiation meter. So if it is it's called a pyranometer. The pyranometer would give you incoming solar radiation. So it will tell you the amount of sunlight falling on the surface of the solar panel. That is one thing that is required. Then you should have a energy monitoring system, like a current sensor and voltage sensor, to monitor the amount of energy generated by the solar panel. Now that you have to compare the incoming solar radiation with the energy generated by the solar panel. If it is not matching, then that should give an alert in your IoT system. The IoT system should trigger an alarm saying that the incoming solar radiation is this much, but the amount of energy generated from the solar panel is not fully utilized. So that is one aspect. So then if you consider a battery system, again you need a transducer to monitor the voltage of the thing and also the current. So if the voltage of the battery system is going below, say if it is a 12 volt system, it is going below 11 volts, that means there is a problem with the battery system. So again, with respect to inverter, you could know the amount of energy generated through the DC energy monitoring, and then you would know the energy monitoring from the inverter. So again, if the DC is connected to IoT system, so if there is a the efficiency is less than 80%, then there is a problem with the IoT system should give a alert through the software from on your mobile phone. So these are various alerts that you can utilize. Of course, there are other alerts, like if there's a fuse or any other control. So when you get these alerts, then automatically You can control the electrical system, or say you can actually automate a call also to do this. So, and with respect to a system like this, you could also get some kind of a surveillance. Previously, it's called SCADA. Right, today IoT does all these things to monitor the energy meter and give these alerts on your mobile phone or your desktop application for you to take corrective action. So this is how we are automating the performance based monitoring system.
Thank you, sir. Thank you, sir. It was elaborate answer. Thanks for that. And there are some two questions from the same person. One is Harija Rani. She is asking two questions. In that, the first question is, which software is used for the design verification before prototyping? I think it is already answered, or if you can take up that, that's also fine. That is the first question. Which software is used for design verification before prototyping?
Yeah, as I said, we could use LabVIEW based system based thing for design verification. Yeah, it's pretty expensive software, but it really helps.
Okay, and the second question from the same professor is Harija Rani. She's asked like, data acquisition system will provide battery SOC information or not?
Yeah, so SOC, as I understand, is a system on chip, right? So the system on chip would have UART. If the battery has a SOC in it and UART communication in it, then you could actually utilize that thing to the data acquisition system. So if there is a SPI protocol or something like that, then again you can actually access the battery information. Nowadays, the batteries are enabled with such thing. So if you want to elaborate on the question, please go ahead, ma'am.
Sir, sorry for interruption. SOC means state of charge, sir. Battery state of charge I'm talking about.
Okay, you are talking about the state of charge. So I was thinking if the advanced term was system on chip. Okay, yeah. So there is a state of charge of the battery is measured through the voltage levels, right? So if it is the state of charge for 12 volts of a battery, it is fairly charged. If it goes to 12.2, then again it's the state of charge is fully charged. So if the voltage level is 11.2 or 3, if you monitor it on a data acquisition system, you know it's still in the charging mode. It is gone beyond 11, below 11 volt, the battery is defunct. So the data acquisition system can actually help in understanding through this voltage levels if you are talking about a lead acid battery. But these voltage levels are very different for a lithium-ion battery or ultra capacitor. So yeah, data acquisition systems can actually do that work by when you actually program it for the right voltage levels.
Okay, sir. Okay. Thank you, sir.
Okay.
You are most welcome.
Professor is satisfied with the answer, I think. Sir, there is one question from our professor C.R. Rajshekhar. Okay.
Sure,
he
sir.
asked like, can you give a demo for the participants?
So right now there is as I said, this is a hardware demo is very difficult. I can't really show, but I mean it is. Okay, 1 second. I'll see if I can show a software demo.
I know it is very difficult. It was not included in the presentation. So if it is possible, it is very nice for our participants.
I'm just seeing if I have some files that I can open it up.
Ganesh, if it is possible only, please. Otherwise, it is not necessary.
Yeah, because it's also, if I show some customer data, it is also not.
It's okay. It's okay, Mr. Ganesh. No problem.
Okay, sir.
No problem. We can arrange one more session specifically for
I'll actually share a link where I'm demonstrating to Shri Union Minister Shri Ravi Shankar Prasad ji. I'll share that link right away. If you can actually go through that video, I've actually demonstrated to him, and that demonstration is very helpful.
Yes, sir. If you share that link, it is a benefit for our.
Yeah. So here is our link. So this is the demo I'm giving to our this one. Here is a link, sir. Presenting our work to Union Minister Shri Ravi Shankar Prasad ji. This link has the demo of the complete solution. So please feel free to. You can actually show this demo. I don't know if you can show the video right now, but I don't know. I'm sharing the. Can I share the screen? Can I share the screen?
Yes, sir. Please share the screen.
Just a second. Yeah. Please let me know, sir, when my screen is visible. Is my screen visible?
It is seen. It is seen.
Yes.
You are seeing. Whatever you are presenting is seen, sir.
Yeah. So I don't know if audio is coming.
No audio.
But yeah, you can see the video, I think so.
Yeah. We could able to see Honorable Minister.
Yeah, I am actually. So I'm explaining him how we reduce the water consumption. You can see the software running in. You can see the software is actually, I'm explaining him how the software works. I'm telling him how we are monitoring the wastage in this, how we are tracking the water infrastructure I am showing. I am showing him how we are using machine learning algorithms to find out leakage wastage. Yeah. And I've been telling him the software, which is a web application software. Yeah. So, yeah. So this was the demo I'd showed it to the minister. I hope this was useful. I don't know.
Yes,
Okay.
definitely it is useful. This is the information for our participants. In the month of coming December, we are going to arrange one practical session completely for this energy sustainability using IoT for about a week program. Morning session theory, and in the afternoon session it is a totally practical session. We will inform you all. Those who are interested, you can definitely join. I request once again Mr. Ganesh Shankar to support in that regard during the month of December.
Absolutely, sir. It will be our pleasure. Happy to do that workshop and share our knowledge. I'm very excited about the kind of questions asked already. So this was a great. You said when people ask questions, we also think. So we had all the honorable professors with great educational background asking these questions. So I think this was great. I would be happy to. Our team would be happy to do this kind of workshop in the future as well.
Thank you, Ganesh Shankar.
Sir, thank you, sir. There is one more question, if you can take up.
Sure, sir. Please.
From Professor Padala Sujata.
Yeah, please.
Madam
please.
asked regarding how can a neural network be used for IoT?
So basically, IoT is only a sensor. You get sensor information from IoT. So at the end of the day, taking action. So the brain of our system does the work of taking action. So basically, hand, mouth, all sensors. So IoT is basically sending this data. So by IoT itself, you can't use neural network, but once the data from IoT comes, we could definitely use neural network system to take corrective actions. In our case, we were trying to use IoT data to find out if there's a leakage wastage. So you can use something like a convolutional neural network kind of algorithms to find out if there's a leakage wastage of water, and that's how you can take advantage of neural networks in IoT systems.
Thank you, sir. These are the questions asked. If any of the participant want to pose the question directly, you can switch on your mic and you can ask the resource person, so that he has a shortage of time. In fact, his time is up. But if anyone wants to ask, you can ask at the
Yeah, I am
short,
also available with my email ID. I am again sending it. So any question can be put here.
Okay.
Happy to get back this one. Ganesh at FluxGen Tech or S Ganesh at I have another email ID is Ganesh at alum.isc.ac.in. Any of this thing, please feel free to contact me. Happy to help in whatever ways possible. Thanks again for the wonderful opportunity, sir. I mean, this was great learning.
Thank you, sir. Thank you, sir.
Thank you. Thank you.
Yeah, just for your information, I am going through the charts. All the participants are expressing their satisfaction and their appreciation for the wonderful presentation from you, sir. There are a lot of appreciation. There are very useful information like that. The list goes on. From all the participants, the professors are definitely highlighting about the knowledge what they gained from your presentation.
It's all people are very kind and generous. Thank you so much, sir. I mean, happy to have got such good response. So in the ocean of knowledge I could share, I have only a drop of knowledge that I could share today. So my knowledge is only a drop of ocean, but you all are ocean. So I always think you're all very generous. Thank you so much.
Thank you. Hope there is no other questions from the participants. Just to conclude, sir, it was definitely, even from my side, as participants mentioned, it was highly informative. And also we appreciate, starting from the presentation, like which you have provided electrical energy for the villages, where that too mainly you mentioned about the education. The percentage of 10th passing has been increased after you providing the electrical energy to the villages. That was really fantastic. We appreciate for the work what you did. And you have covered about the solar panels, you have covered about IoT system applications. Most importantly, what I noticed is you have given up a lot of opportunities for the professors to take up the research activities in this line. From your presentation, lot of opportunities are available like that we could able to understand. And I think professors have noted down all the points. They may take up some more research work on that line. So it was highly informative. Thanks a lot. Thank you very much for the knowledge what you have gained for sharing with us.
Thank you so much, sir.
So it's my pleasure and it's my duty also to thank you on behalf of the Department of Mechanical Engineering, MITE, for sharing your valuable time and sharing your valuable knowledge what you have gained throughout your education and your experience for all of us. Thank you once again, sir.
Thank you. Thank you, sir. Thank you.
Dear participants, we can wind up the session. So good night. We'll meet tomorrow in the morning session from 9:30. Good night to all of you.